There's a little bit of a skip coming in from Jamaica. Just starting to come in a little bit today. Nope. I don't think there was anything on, nothing on 385. Like I say, just starting to come in a little bit. A little bit coming in down here somewhere. Yeah, there's 26715. A little bit coming in from Mexico. So I have not done the transceiver alignment on it. That's the only thing that needs to be done on it. It's already a good receiving and transmitting radio. So the only thing I really did, I showed you how to, in a separate video. Actually, I don't know if I actually even started this video. Because I did another video on this about removing glue. So I don't know if I actually even have got another section of the video for this. So I may need to start off with what this is. President, HR2510, kind of obvious. Customer sent this in. It's been sitting in a closet for like 20 years. So it hasn't been used in a long time. Wanted it basically 100,000 mile tune-up, kind of as I jokingly call it. Replace the electrolytic caps, get the corrosive glue out, which I know a section of video I did shoot. Found a new trick for getting the glue off of stuff like the toroid transformers that works really well, so be sure to watch that video. Very time-saving method there. So that's what I've done. I've cleaned the glue out, changed the electrolytic capacitors. Basically, other than that, just a simple cleanup on it. Like I say, the only thing I have left to do to it now is the transceiver alignment. It's receiving pretty good right now. It'll pick up a little bit more because FM is just booming in on this thing. Sideband's a little bit low, so yeah, I can tell it needs to be tweaked, but it is receiving good. If the customer got this back and just hooked it up on air, it probably wouldn't really notice a huge difference. Frequencies are actually very close on this. Actually, just turn it back on. Get off the antenna. And let's see, we'll just stick it on center of CV band 27. Actually, there's a signal being injected into it right there. So actually the meter is off because I'm injecting minus 73 dBm right now, and that should be an S9. So yeah, the meter's not calibrated properly. But let's see here. For starters, let me turn that blasted tone down. So let me just key the microphone. And 36.3 dBm, so just a little bit over 4 watts, and 27.204919, so yeah, it's off by about 80 hertz. So really, really close. Considering it hasn't been used in 20 years, that's really close. In sideband, when I was listening to sideband there, the clarifier is, just a gnat's whisker away from dead center. So I've seen some of these things, man, the frequencies would just be off horribly on these sometimes. But, so yeah, good working radio even before an alignment. Like I say, it does need a little bit of fine-tuning and finessing, but for the most part, it's in really nice operating condition right now. Blasted accessory plugs are always hard to get off. Of course, I've got a few extra pins in my bench one because I've got the CW jack and the speaker jack on it. But one thing I did have to do to this, and the customer had mentioned it, was the channel selector. I don't want to say it's a known problem, but if you own one of these, you may or may have not run into it. You'll turn the channel selector, your frequency control, and sometimes it'll work, and sometimes it'll jump several digits, and it's it's all wonky. What else can you say? It's all screwed up. Now, this is not a channel selector switch like you're probably used to in most other radios, where it's a wafer switch. This is a rotary encoder. So, now it looks like a normal switch, big switch, and if you pull it out, it even says Accord on the back of it. It looks just exactly like the channel selector switches that you would have found in Uniden CB radios. Shoot, Rangers, Galaxies. I mean, for decades, they made channel selector switches. Well, basically what Accord did is they just used a housing they already had, and instead of sticking a wafer switch element in there, they just turned it into a rotary encoder. So the difference with a rotary encoder is that's what you use with microprocessors. So it counts. There's basically, and I actually had to tear that apart. I wish I would have shown that. I may do that some other time, do a separate video when I rebuild one of those. But they are repairable. They are no longer made. Now, if you own a Ranger, for example, one of the Ranger 10-meter export radios, they have one that looks exactly like this. It sits on a little circuit board, 3 wires come off of it with a plug. Same thing. They can't get them anymore. Now, Ranger came out with an update board, and it uses a modern, really small type rotary encoder. I really don't like those, the tactile, you hear that? The clickiness, yeah, it's the ones that they use. It's really hard to get good rotary encoder. It's not so much that the quality of the encoder, but it's the rotational force. There's a specification on the data sheets for encoders, the rotational force, to overcome the force of the detent to get to the next position. The modern ones just don't have much rotational force. They're not clicky, and I like an encoder that's, I don't want to be able to just accidentally bump it and it changes channels. I like to have a little bit of force there at least. And that was what was nice about the Accord style. The problem that I found with these is it's not that they wear out. So internally there's actually five little spring fingers in there. 3 of them are used, 2 of them are not. For a rotary encoder, you'll use 3 terminals. So it'll have one's basically or 2 of them. What it's doing is it's pulsing. Okay, and on the little disc that those fingers touch, it's like a little window, and when it passes the window, it's telling it, and it's a double rows of windows, and that's what those little fingers are doing. So it knows that if this finger makes contact before this finger, you're turning the selector switch one direction. If this finger gets contact before this finger, it knows you're turning in the other direction. The problem is those fingers, and it's not that they wear out either. There's plenty of metal there. They're not even barely worn in this one. The problem is they've lost their spring tension over the decades. You remember, this radio's got some age to it. We're going back into the 90s. So, they're supposed to be up tight against that disc. Well, they just lose their tension. They start to lose contact, and it doesn't take much. It's not that it's not touching. It is. The problem is you start to get bounce. And that's, if you know anything about microprocessors and rotary encoders, debounce is a very important part of programming the code. And that's what happens. It'll start to bounce. Because that's what I say. You'll turn it, and all of a sudden you'll change like 6 channels. Or, 6 steps of whatever the frequency span you had set to. That's because it's not making tight contact, and it's actually bouncing as it skids across it. So all you got to do now, they weren't meant to be taken apart. They actually have, you see this white plastic here. Normally there would be 4 little round plastic pieces that come out the back of this metal right here. And then they just melt it. They heat the plastic up and kind of squeeze it, smushes it out, and it sandwiches that entire switch section together. They're fairly easy to fix. It takes a little bit of time, but they're not that hard to fix. Just pull it out, desolder it off of the board. Take a pair of flat wire cutters, ones like this that cut, flat. Just snip off those 4 little plastic ears that stick out the back. Pull the metal plate off the back and pull the first little plastic section off, and you turn that over, it'll have those 5 little contacts in it. Now I usually clean the disc that's in there with a little bit of isopropyl alcohol. Same thing with the fingers. I'll take a fiberglass brush, lightly clean them. I apply a little bit of deoxit shield to everything in there. But the main thing you want to do is, and don't get drastic, but the spring fingers, like I say, they're touching, but they've lost most of their spring tension against that disc. Just bend them up slightly. That's all you got to do. Bend them up a little bit, reassemble it, and then I take a pin drill with, I think it's like a number 61 numbered drill bit. and I drill with just a pin vise, by hand. I'm not using an electric drill. I just drill 4 little holes in the center of the plastic that's in there, and then you can see there's teeny tiny little screws in there, and that's all I do. I screw it back together. So from now on, it's easy to rebuild, or to do that if it ever happens again. The hard part's done. Just take the 4 screws out, pry the fingers out a little bit, put the 4 screws back in, pop it back in a radio, and you're done. So like I say, that's working fine now. I didn't get it to skip. It was just horrible when I first started, and it's perfect now. So like I say, it's an easy way to save those switches. Again, remove the corrosive glue, because there's corrosive glue on this board, the capacitors, this resonator, and both of the voltage regulators here. Now when I take it off the voltage regulators here, the way they have pretty much a lot of these components, like your transformers, you can see there's actually a little bit of masking tape underneath of it. They did the same thing on both of these voltage regulators. The problem is they put the corrosive glue down on top of it then, and it starts to eat everything away. I take that corrosive glue off, but you have to remember those tabs, you don't want those touching the traces just in case, and that's why they put tape under there, because they don't want a chance of that ever shorting out against one of those traces. So I just take a little sill pad, little, thermal pads like you would use on transistors. I put a sill pad underneath there, and then I put some conductive glue on there. The reason I do that instead of re-gluing them back down with normal glue and just a piece of masking tape is I'm trying to actually dissipate that heat into the board a little bit more. If I can do that, remember there's crystals on this board, and that's what sets your frequencies in this radio. So if I can warm this board up a little bit more evenly, I might as well use a heat source. I've got two heat jams. I mean, don't get me wrong, the processor and the other ICs get warm, but those are the 2 hottest parts on this board. And it's not that don't get me wrong, they don't get really hot. But if I can transfer that heat into the board's, the structure of the circuit board and get it to dissipate through the board, it actually helps to warm this board up faster and keeps it at a constant temperature a lot better, which leads to better frequency stability, because we don't have crystal ovens. They're just crystals plopped on a board. So that helps to, these are stable radios to start with, but that can actually help a little bit to make it even a little bit more stable. And the components will last longer because they're not getting as hot. They can more efficiently transfer the heat into the board instead of just trying to, the heat didn't really go through the masking tape very well. It just kind of had to rely on convection, releasing heat into the air. So, board was all cleaned up. See, it's nice and shiny, all the flux residue removed. And that's pretty much it. So what I'll do is I'll go ahead and do the transceiver alignment on this now. It is a bit of a chore on these. There's a lot, because this is an export multi-mode radio, in addition to AM and sideband, it has FM and CW modes. There's, extra adjustments for that. This is also a fairly broad-banded radio, covers a fairly large frequency span. So it just has more alignment points than your standard CB radio. Actually, even more than most of your what I'd call black box export radios. These were pretty good radios. Don't get me wrong, this is not what I consider a true amateur radio, but it's about as close as you're going to get that was built back in the day. The board quality is about the same as you'd find in any other CB radio made in the day, but quality of components, they put a little bit more time and effort into building these radios, and they are really nice radios. I've got some of these. I've also had the original President Lincolns, which look exactly the same as this, except some of the buttons are colored a little bit differently. What is the other? There's one other feature, actually a reason I like. I can't remember. I have to go look at it. I like the President Lincoln. One of these buttons is different. I can't remember what it does right off the top of my head. But internally, it's basically the same radio. But yeah, really nice. Like I say, I lucked out. I was able to get the glue off of these things with that. Like I say, you have to go watch that other video. I'll probably title that something like "Get the Glue Out," or how to remove corrosive conductive glue. But yeah, I discovered a new method where it just, I don't want to say it melts off, but it re-rubberizes it, and it's just, you just take a brush and brush the stuff off. Yeah, it's just something, I don't know why I didn't think about it until now. But, so, anyhow, let me get done the transceiver alignment, and we'll see how this thing performs when I get done. Okay, so the alignment's been done on this. Good working radio. Sensitivity did pick up on it. One thing I wanted to try on this with one of the, I've bought more than one in the last several weeks, communications test sets. Yeah, I'm running out of radios to buy, so now I'm starting to collect test equipment. But this one does a lot of really nice automated testing, and one of the things it'll do is it has the ability to do, or to create 20 audio tones at the same time. It has it has several audio options built into it, and all of those together allow that what they call a 20-tone test. And you can do transmit and receive tests on that. What I wanted to check, now I know these radios pretty much out of the box. These things are pretty broadband actually out of the box. Probably, like, if you're lucky, 5 dB down at 5 kilohertz. I mean, if that, they're really broadbanded audio-wise on AM. But I wanted to actually AM, FM, pretty much all the modes. Sideband, of course, is pinched by the crystal filter, but AM and FM are extremely wide in their audio transmit response. But what I wanted to check was the receive audio response. Most CBs, yeah, and actually export 10-meter radios, honestly, they suck. I've seen some of them that are flat for, if you're lucky, 300 hertz, and other ones that are great. And I've never checked one of these. Now, the way I used to do it was a pain in the butt. I had to use 2 signal generators. One sweep signal generator as modulation for the RF signal generator. And even then, it's not a composite tone. It's not 20 tones being transmitted at the same time. It's a sweep through whatever you set the frequency range to. This one, like I say, actually will inject a modulated signal with 20 audio tones. So that really helps to simulate voice transmissions, because when you're talking, there's lots of different tones all happening at the same time. You know, you've got your voice cords making sounds. You have your tongue, your lips, controlling sound. There's lots of different audio frequencies happening at the exact same time. And that's pretty much what this test was designed to do, was to simulate real audio like you have in the real world. It's going to be more than one pure tone at any single instant in time. It's going to be several audio tones at the same time. So I actually have it set up for that. Actually, I do need to change the radio around here. Get the antenna unhooked and get hooked up. Oh, come on. Get that hooked up. And then we can look up here. And when I turn the volume up, the camera swung around here a little bit. Okay, turn the volume up. And I hope I put it on the same channel. So that's a composite audio tone, or 20 audio tones. So this bottom line here is the line that we're using. That's the actual frequencies that are being used for modulation. So from 240, 500, 750, 1000, 1300, up to 400 here. And if I scroll, it'll only display up to 14 at a time. But if I scroll right, see the highest frequency there is 6000 hertz, which pretty much any radio is going to fall flat on its face. Once you get up, like you can see here, at 4600, there's almost nothing at all. But, get rid of that little window there. But what this uses is, you pick the tone, and on radios like this, usually your standard signal used as a reference is 1 kilohertz, or 1000 hertz audio tone. So let me turn the audio down slightly here, so it's not blasting you out of your chair. Excuse me. So the 1000 hertz is being used as the 0 dB reference line. So there's the 0 dB line. And then all of these other signals, this bottom line here, you can see as they're changing, as the signals bounce around a little bit. But those are how many dB down or above from the 1000 hertz tone that those signals are being received. So, that's the signal coming out of this signal generator into the antenna jack as a modulated RF signal. the radio demodulates it, and then I have a sample port coming off of the speaker. You know, the external speaker jack comes into the communications test, back into the communications test set, and this is then displaying all of those audio tones after they've been demodulated. And this one's actually surprisingly flat, relatively speaking, compared to most CD export radios. Darn it, let me get a drink of coffee here. Much better. I had one actually on here yesterday, which was, God, what was that radio? I'm trying to think. Oh, Cobra 148 GT. That one was the DX, I think. That was the 148 GTL DX. And quite honestly, that I'm not going to say it sucked. It sounds good, listening to stuff on air, but it's definitely not going to be as good as this one. By the time you got to like 1900 hertz on that radio, you were at like negative 15 dB, or 15 dB down from the reference level at 1 kilohertz. So this one's actually pretty good. It's not 10 dB down until you get to right around between 2500 to 2800. You can see that one's bouncing. Yeah, actually right around there's what, 9. Actually 2800. Yeah, 2800's bouncing around right around 11 dB down. That's surprisingly good. Darn it. Something stuck in my throat from dinner. But yeah, I was really surprised. Like I say, I know these things had very broad transmit audio frequency response, but I've never swept the signal through. Like I said, it was just a pain in the butt doing it the way I used to do it. It worked fine, but like I say, it's not. I like this test a lot better. One of the main reasons it's taken me years to find one of these with all of the exact options you need. It's a very precise set of options you have to be able to do the tests that I wanted to do with this instrument, and I finally found one. But this was one of them. And like I said, it's nice because that 20-tone composite test is more realistic. Like I say, when you're talking, it's not just one single tone. There can be background noise. There can be somebody else talking. You're talking. Like I say, the sounds coming out of your, basically out of your face, because it's more than just what's in your mouth. Your lips are making noise. It's a very complex audio signal. This helps to simulate that, in instrumentation where you can measure, because it knows exactly the audio signals it's sending out, and that's one of the things. The audio generator in this is a low distortion audio signal generator, so it has a maximum of 0.05% audio, or 0.05% distortion on the audio frequency, so it's extremely low noise audio source, which makes it very reliable for doing precise measurements on audio frequencies. That's another reason I wanted this. I can use it for more than just working on radios like this. I can also do this exact same test, just send that, instead of using it to modulate a signal, I can take that 20-tone composite, and I can change these frequencies to anything that I want. Actually, I can do a line of another 20 up on the top here. But I can change these frequencies to whatever I want, and I can just send them out as an audio signal. So I can run those into an audio amplifier, like a home stereo amplifier, or a guitar amplifier, or any type of audio amp, and again, send a sample of that audio back into this, and I can measure the audio characteristic response curve of any audio amplifier. So yeah, it's just really nice. Like I say, one of the main reasons I wanted one of these. Finally found the one with all of the impossible to find options. Only option it didn't have was the FM MPX stereo signal generator, which I'm going to have to buy the option for that. Already called a distributor, so they're going to get back to the price for me. But yeah, definitely I'm going to get that. Don't need that for radios like this. I need that for working on stereo receivers. But so I just thought I'd show this. Like I say, surprisingly broad. I mean, I know they're nice radios. People really like this thing. So actually, I guess you could say the only really limiting factor in one of these radios, as far as receiving transmit audio, it's not going to be the radio itself, or the circuitry of the radio. The main limiting factor is going to be the speaker, because it's putting it out through the speaker jack. The problem is the speaker in this radio, so if you just connect a really good external speaker to one of these radios, man, they'll be fairly broad receiving radios and sound really good. They do sound good out of the box with the, what you'd expect out of, let me grab the cover here, out of one of these little teeny tiny speakers. I mean, they're not very big, but like I say, man, you put a good speaker on the backside of one of these things. It has potential for really good quality audio, receive audio. So there you go. This just goes to show it's not like I said. I knew they were broad on transmit. I didn't think they were that broad on receive, though. A lot of times radios will be maybe a little broad on transmit, but the receive audio is so pinched that kind of sucks. Now there is a downside to that, noise. That's one of the reasons you want to narrow your audio response on a receiver. Is the broader the receiver is, well, that's the more stuff that can get in the front door gets out the back door. The front door being in the antenna jack, and I guess you could say the back door is the speaker. So that's the one advantage of having pinched receive audio. That's why sideband. When you switch a radio over to sideband, there's so much less noise than there is on AM receive. That's because sideband has a very narrow crystal filter. Matter of fact, it's right there. That's that little silver box right there. Where AM does not have. They use ceramic filters. But like I say, the advantage of that narrow filter is to not only to filter out, this is used in receive and transmit on sideband, but it really helps to cut out a lot of noise. Downfall there is you lose some audio fidelity because it's cutting off audio frequencies. Usually these things will cut it off well before you get to 3,000 hertz, and the low end they're usually fine. It's usually the top end is where they really once it hits the knee of that filter curve, the audio just disappears. But AM, it's the same principle. The narrower you make the audio bandwidth, the less noise there's going to be, so the less hash and trash you're going to hear, but you lose audio fidelity. You open up the receiver's audio bandwidth, again, you let more noise in, but if you're talking to someone with a fairly strong signal to start with, well, they're probably completely muting all the background noise. You're hearing nothing but them, and then you get a good full-sounding audio. So, yep, President HR2510 or the original President Lincoln. Like I say, I've got both. This one's not my radio. Like I say, it's customer's radio, but I have both of them. They're pretty much exactly the same, except for just a very few minor changes on the front panel here. Little bit of change in the control and buttons, the color of the buttons, yeah, so very surprised. Good. I knew they were good receivers, just didn't know that AM and FM receive was as broad as a side of a barn. So there you go, another HR2510 ready to be put back into service.